So explanation first. What was the goal and what was my motivation? So from my other videos, you know the project with the cheap BLDC controller, this one over there. I'm not very happy with this one because the control from the wheel backward to forward, the switching time is too high. It took up to 500 milliseconds, and I have to wait until the wheel stops by itself before I can control the other direction. So for dynamic robot project, that is not very good. So for a scooter, for human transport scooter, this maybe works very well, but for dynamic robot it's not very well. So what I have figured out is this. You see these two hoverboards, and I hacked them. I hacked the motor controller of each one. So you see these massive wheels. The weight is approximately 5 kilograms of each wheel. It's 8.5 sol. Or inches, you call it inches. So, and what I need is for dynamic robot control or dynamic control of the wheels is this motor controller. And here you see what I have done is I disconnect the original gyro. You see the connector 1, connector 2 is disconnected. Connector 4 is over here disconnected, and 3. This was 3, and this is number 4. And as an exchange from the gyros, I use this little Atmel controller. You can also use an Arduino. What you need is this little small logic line of the UART or RS232. The TXD data line. It's the output TXD from the Atmel controller. It's 5 volts. This is running at 5 volt. I need a 3.3 volt for the motor controller. So I have this little voltage limiter. So some diodes. And what I have done exactly is I put this signal, the TXD, on all 4 inputs. Each hoverboard has 2 inputs, 2 RXD from the gyro. From the gyro to the motor controller, and I put the signal. Over there is one signal, the second signal is the same signal, the same TXD, and also the same TXD goes over here, paralleling to this connector over there, and to this connector over there. You see it? This is my signal. So now the original gyros doesn't give the information. It doesn't running anymore. All 4 gyros doesn't run. So what I have done is to control it with these 2 buttons over here. And now I show you the dynamic. And it's real awesome. So first we have to power on each hoverboard. So I did it. One time the first hoverboard is running. I show you the effect. First hoverboard running. So you see, I'm pushing forward, backward, forward, backward. Okay. So the point that the wheels turning in different directions is no problem, because in a robot project I will take the second wheel and demounting it and put it on the other side, so both wheels will run in the same direction. So perfect for the robot with 4-wheel drive. So now I power on the second hoverboard. You see. Okay, and now both hoverboards running. And you see the dynamic? It's jumping. So this is real dynamic. This is awesome. You see it? Maybe I show it like this. and this is only 10% of the value I can send to the motor controller. Now I'm sending only the value 150 decimal plus and minus 150. So the range of the value is from 0 to 1600, and I'm able to spin every wheel up to 11 revolution per second, or rotations per second. 11, that times out to 660 RPM. And the original hoverboard only drive with a maximum speed of 300 RPM or 5 rotation per second. And so I have much more speed, and the motor controller doesn't react with an error. So all 4 inputs are paralleling by me, and it's working fantastic. You see the dynamic? This is awesome. Okay, in the description I will write more details from the controlling the inputs. Okay, that was it for the moment. And I guess this is a good choice for dynamic roboting.